Grade 12s, and welcome again. We are going to be starting on geometric sequences. So the formula that we are going to be using is Tn is equals to a times r to the power n minus 1. Now this formula is on the information sheet. Please note that geometric sequences are also called exponential number patterns. There's part 1. I am simply going to give you some time to copy it down. Okay, so the first question is, given the geometric sequence 4 and then 20 and then 100. 1.1 states, calculate the next 3 terms in the sequence. So first you have to label it. This is T1, this is T2, this is T3, right? So the next 3 terms will be T4, and then T5, and then T6, right? So since this is a geometric sequence, we're expecting a constant ratio. So in order to get it, we're just going to say T2 divided by T1. So T2 is 20 divided by T1 is 4, which is 5. So T4 is T3, which is 100 times 5, which is 500. And then T5 is 500 times 5, which is 2,500. And then T6 is 2,500 times 5, which is 12,500. And then 1.2 states, determine the general term of the sequence. So we know that general term is Tn is equals to a times r to the power n minus 1. So we need a and r, right? So a is T1, which is 4. Then do not forget r is T2 over T1, which is 20 over 4, which is just 5, right? So Tn is equals to, where there's a we put 4, where there's r we put 5 to the power n minus 1. So final answer, Tn is equals to 4 times 5 to the power n minus 1. In case it wasn't clear enough. So 1.3 states, which term in the sequence will be equal to 312,500? So we only know that Tn is equals to 312,500. What is the formula for Tn? Here it is. 4 times 5 to the power n minus 1 is 312,500. We divide everything by 4, right? So it's going to be 4 times 5 to the power n minus 1 over 4 is equals to divided by 4. This goes, this goes. So we have 5 to the power n minus 1 is equal to, so we get 78,125. Right? So now we need to write 78,125 as a base of 5. So using my calculator, 5 to the power of 6, nope, that's 15,000. So 5 to the power of 7, aha! So 5 to the power of 7, that's what I get on my calculator. 5 to the power n minus 1 is equals to 5 to the power of 7, right? This is 5 to the power of 7. So you drop the bases and equate the exponents. N minus 1 is equals to 7. Therefore, n is 7 plus 1. N is 8. So T8 is equals to 312,500. Okay, the second question goes, given the geometric sequence m and then 2m squared and then 4m cubed. A is, write down the next two terms of the sequence. So first you label, this is T1, this is T2, this is T3. Okay. So the next two terms will be T4 and T5. Right? So you just need to find R. R is T2 divided by T1. So it's 2m squared. Okay, so R will just be 2m squared over m. You'll do that on a side piece of paper. It gives us 2m, right? So T4 is T3, which is 4m cubed, times R, which is 2m. And we get 8m to the power of 4, right? T5 is T4, which is 8m to the power of 4, times R, which is 2m. And we get 16m to the power of 5. B states, calculate the nth term of the sequence. Nth term, okay. So we know that the formula for the nth term is Tn is equals to a times r to the power n minus 1, right? So we need a and we need r. A again is T1, which is m, right? R, even though we calculated it, we have to show it again. R is T2 over T1, which is 2m squared over m. So R is 2m, right? Tn is equals to A is m times R is 2m to the power n minus 1. So hope that is visible enough. Okay, number 3 states, given the geometric sequence with third term negative 90 and sixth term negative 2430, Roman numeral number 1 states, determine the value of R, the constant ratio. Okay, here is what we are going to do. So we are given that the third term T3 is negative 90. Oh, sorry, let's just start with the formula. Tn is equals to A times R to the power n minus 1, right? So T3, where there's n, we put 3. So it's going to be A times R to the power 3 minus 1. What is T3? Negative 90 is equals to AR squared. This is equation number 1, right? And then we are given sixth term. So where there's n, we put 6. A times R to the power 6 minus 1. We're given that T6 is negative 2430. So negative 2430 is equals to AR to the power 5. This is equation number 2, right? Since we are dealing with exponentials, we are going to divide in order to get rid of something, right? So it's going to be equation number 2 divided by equation number 1. So it is going to be equation number 2. On the left, we have negative 2430, right? Equation number 1, on the left, we have negative 90. Equation number 2, on the right, we have AR to the power of 5. Then equation number 1, on the right, we have AR squared, right? So you can see the A's cancel each other out. We are left with negative 2430 over negative 90 is equals to R to the power 5 over R to the power of 2, right? And then just work that out on the calculator. Negative 2430 divided by negative 90. We get 27 is equal to R to the power 5 divided by R to the power 2 is going to be R to the power 5 minus 2. So 27 is equals to R to the power of 3. How do we get R? Just take the cube root. R is the cube root of 27. So R would be cube root of 27 is 3. So R is 3 by calculation. Then number 3, Roman numeral number 2 states that find the value of A. So we found R, now we have to use it to find A. Let's just use equation number 1. So it's going to be T3 is equals to, you don't have A, R we found it, it's 3 to the power 3 minus 1. What is T3? It's negative 90. 3 to the power of 2. So negative 90 is equal to A times 3 squared is 9. Negative 90 is equals to 9A. Then we divide both sides by 9. This goes. Therefore, the answer that we get is A is negative 10. And then Roman numeral number 3 states that determine the general formula of the sequence. So general formula, we know that it has to be in the form Tn is equals to A times R to the power n minus 1, right? We just got that A is negative 10 and our R is 3. So it's going to be Tn is equals to negative 10 times 3 to the power n minus 1. So the formula is just Tn is equals to negative 10 times 3 to the power n minus 1. Okay. Question number 4 states, given the geometric sequence 4 and then 2 cos theta and then 1 minus sine squared theta and then others after that. 4.1 states, write down the next 2 terms of the sequence. So first we label it. This is T1, this is T2, this is T3, right? So the next 2 terms is T4 and T5. T4 and T5, right? So again, first we have to find R. So on a piece of paper, just do this. R is T2, which is 2 cos theta, over t1, which is 4. And we get half cos theta. Sorry about that. So t4 is t3, which is 1 minus sine squared theta, times half cos theta. Okay, so what I want you to note is that 1 minus sine squared theta is the same as cos squared theta times half cos theta. Oh my, okay, I'm running out of space. Forgive me. I'm just gonna have to cancel this and this. So t4 is, it's 1 times half, it's half. Cos squared theta times cos theta is cos cubed theta, right? And then t5 is t4, which is half cos cubed theta times half cos theta. So 1 over 2 times 1 over 2 is 1 over 4. Cos cubed theta times cos theta is cos to the power of 4 theta. Sorry about that. It will be clearer in the memorandum. 4.2 states, calculate the nth term of the sequence. Okay, so once again, nth term is this, Tn is equals to a times r to the power n minus 1. A is 4. And then r is T2 over T1, which is 2 cos theta over 4, which is half cos theta. Tn is equals to, where there's a we put 4, where there's r we put half cos theta to the power n minus 1. So therefore Tn is equals to 4 times half cos theta to the power n minus 1. Okay, grade 12s, just take a short break and be ready for part 2. So this is part 2 of geometric sequences. Okay, grade 12s. So the first question states, consider the following geometric sequence. You have negative 16, and then negative 20, and then negative 25. Then you have other terms in between, and then you have negative 15,625 over 256, right? 1.1 states, calculate the next two terms in the sequence. So we have T1, T2, T3. Then we have those in between. We don't know what term this is, so it will just be Tn, right? So we just need to calculate T4 and T5, right? So T4, T5. We are given that it's a geometric sequence, so we have to find the constant ratio, which is T2, which is negative 20, over T1, which is negative 16. So the constant ratio is 5 over 4. So T4 will be T3, which is negative 25 times 5 over 4. Okay, so negative 25 times 5 over 4. So I'll write it in fraction form. It's negative 125 over 4. T5 is T4, which is negative 125 over 4 times 5 over 4. Which is negative 625 over 16. Alright, so 1.2 states, write down the general term of the sequence. So general term, Tn is equals to a times r to the power n minus 1. So a is T1, which is negative 16. Right? R is T2 over T1, which is negative 20 over negative 16, which is 5 over 4. Right? Tn is equals to a is negative 16 times 5 over 4 to the power n minus 1. Negative 16 times 5 over 4 to the power n minus 1. Determine T6. So we're just going to use this formula, right? T6 is negative 16 times 5 over 4 to the power, where there's n we put 6, so it's going to be 6 minus 1. Over 4. 6 minus 1 is 5. So, sorry about that. It's negative 3,125 over 64. You can leave it in fraction form, or if you use exam rules where 2 decimal places apply, it's just negative 48.83. And then 1.4 states, how many terms are there in the sequence? Now this is very interesting. So we don't know how many terms are there in the sequence, right? All we know is that Tn is equals to the last term of the sequence that we are given. It's negative 15,625 over 256. What's the formula for Tn? It's negative 16 times 5 over 4. 5 over 4 to the power n minus 1. Negative 15,625 over 256. We have to divide both sides by negative 16. So we just write 5 over 4 to the power n minus 1 is equal to, so on your calculator it is going to be negative 15,625 over 256 divided by negative 16. Oh my. So the answer that we get is 15,000 625 over 4096. Wow, let's simply use logarithms. Oh, how can we write this as a function of this? Let's use trial and error on the calculator. Okay, so just log both sides. Then we take this comes here. So it's going to be n minus 1 times log of 5 over 4 is equals to log of 15,625 over 4,096. So it's going to be n minus 1 is equals to log of 15,625 over 4,096 divided by log of 5 over 4. So it's going to be n is log of 15,625 over 4,096 over log 5 over 4 plus 1. Okay, let's just do that. Five over 4 plus 1. We get 7. N is 7. So there are 7 terms in the sequence. Okay. And then number 2 states, given the geometric sequence, the first term is 27, followed by V, followed by W, and then 64, and then we have other terms, right? Roman numeral number 1 states, determine the possible values of V and W, and we are given that V is greater than 0 and W is greater than 0. Now this is a bit of a hard one. Okay, so first just write the general formula. Tn is equals to A times R to the power n minus 1. We know A. Okay, supposed to label first, sorry, T1, T2, T3, T4, right? So we know that A is T1, which is 27, right? So Tn is equals to 27 times R to the power n minus 1. We are given T4, right? So it's going to be T4 is equals to 27 times R to the power, where there's n we put 4 minus 1. What is T4? It's 64 is equals to 27 times R to the power 4 minus 1 is 3. So it's going to be R to the power of 3 is equals to, divide both sides by 27, they'll cancel each other out, so it will be 64 over 27. So R is equals to the cube root of 64 over 27 cube root. So r is, so what is the cube root of 64 over 27? It's 4 over 3. Sorry about that, 4 over 3. So T2 is equals to A times R to the power 2 minus 1. We found R, right? T2 is V. Let me just check. Yes, T2 is V. So it's going to be V is equals to A is 27 times R is 4 over 3, which is 36. And then T3 is equals to A times R to the power 3 minus 1. T3 is W, right? And A is 27. R is 4 over 3. 3 minus 1 is 2. So W is 27 times 4 over 3 cubed, squared rather, sorry. And we get 48. So therefore, as we can see, V is 36 and W is 48. Roman numeral number 2 states that calculate the nth term of the sequence. Formula for the nth term, Tn is equals to A times R to the power n minus 1. We know that A is 27. R is T2 over T1. T2 is V, right? T1 is 27. V, we just found out that it's 36 over 27, which is 4 over 3. So Tn is equals to A is 27 times R is 4 over 3 to the power n minus 1. Then we remove the unnecessary brackets. It's just 27 times Roman numeral number 3. Oh my, sorry about that. Roman numeral number 3 states calculate T8. So we just substitute into the formula. T8 is 27 times 4 over 3 to the power of 8 minus 1. 27 times 4 over 3 to the power of 7. Oh my, shouldn't have done that. You can leave it in fraction form. I honestly don't mind. 16,384 over 81. Or if you use the exam rules, where 2 decimal points, 202.27. Okay. Number 3 reads, consider the following geometric sequence. We have 20, then we have 60, then we have 180, then we have other terms in between, and then the last term that we are given is 1,180,980, right? And then number A states, write down the next 3 terms of the sequence. So first we have to label T1, T2, T3, others in between, and then Tn. So we need T4, we need T5, we need T6. So R is, on a side piece of paper, T2 over T1, which is 60 over 20. So R is just 3, right? So T4 is T3, which is 180 times 3, which is 540. T5 is 540 times R, which is 3, and we get 1620. T6 is T5, which is 1620 times 3, which is 4860. And then B states, okay, let's move this here. Calculate the general term of the sequence. Once again, the formula for the general term is n minus 1, right? So A is T1, which is 20. R is T2 over T1, which is T2 is 60 over T1 is 20, which is 3. Tn is equals to A is 20 times R is 3 to the power n minus 1. So we can write it as follows. Tn is equals to 20 times 3 to the power n minus 1. Okay. C states calculate T9, or determine T9 rather, sorry. Okay. So T9 is 20 times 3 to the power 9 minus 1. 20 times 3 to the power 8. So T9 is 131,220. Okay. So the memo is as follows if you don't understand, if you don't see clearly what I've written there. Okay. Here are the answers in case you didn't see my handwriting. That's for part 2. those are my contact details once more. For call and WhatsApp, 082 390 5036. Then you can email me at boduhelptutoring@gmail.com. So if you found any of the stuff that we did helpful, please click the like button and then subscribe to my channel. I hope to see you again. Thanks and goodbye.